Okay, so this is day 3. Now, probably the biggest thing that came out of integration is this concept here, and it's if you find the integral of the antiderivative of the function, you can actually find the area under the graph. So I'm just going to do a little proof just to show you how this was actually discovered. But it wasn't discovered from taking the antiderivative and then finding the area, but taking the area and then finding the derivative of it. And when they did that, they were actually able to find the function. So the whole concept is basically if you want to take area under a straight line, it's very easy, right? You can use your shapes, your triangle, your trapezoid, but when it's obviously curving and doing things very inconsistent, that's not going to work. But you could, if you wanted to, start taking the derivative, or sorry, taking the area of all these little trapezoids, and the smaller the trapezoids, when you added them together, you would get, because it's not a perfect trapezoid, obviously, because it's not, but the smaller they were, the better the approximation you would get. Now, the area function, which is called AX, is uniquely determined by the position P, which would be x comma f of x. Okay, so I'm just going to get rid of this for a second. It's not really part of my proof. So if I put, say, point P there, right, and that would be x comma f of x, because the y would come out of the function, right? Now, we also want to now, to show this, now select point Q, and say we want to put point Q here. Now, putting point Q as close as you can to P would be the goal, but then it doesn't make for a very nice diagram. Now, if we were to come straight down, now we would call this distance here h. And let's call this r, and we'll call this s. Okay, so now you can sort of see our trapezoid. Now, if that's point x on the bottom, and that's h away, this would be x plus h. Okay, this is x. Now, if q would be x plus h, comma, f of x plus h. So we've got point Q, which would be x plus h, comma, f of x plus h. That is close to P. And I just want to make a note. We exaggerated on diagram to see better. But you can see how by putting Q that far away, it's not a great approximation, because look at all of this. Like, that's not even part of it, but it's going to be included in this because of the fact that Q is so far away. But if you had, you know, P there and Q there, you could see you would probably find a very good approximation by doing a trapezoid here, right? Because it's okay, but just is for sake of just the... Now, the area of the curve region, PQRS, is the change in area as x changes to x plus h, okay? So as we move more this way, we get a bigger change. Okay? In fact, the derivative of the area is defined as, so limit as delta x goes to 0, change in x goes to 0, of delta A over delta x. And how do we find delta A? So that's the same thing as the limit at x goes to delta x goes to infinity, or 0, what am I talking about? Infinity, I don't know. Equals, so delta A is A x plus h minus A of x all over. And we can call, oh, so I'm going to change this. Instead of delta x, I'm going to call this h now, as h goes to 0, because I've called this delta is just h. Okay? Now, remember, this is the first principles that we did a long time ago. So this is used for finding derivatives. Now, just to give you a little bit of background on the trapezoid, we always call this A, this B, and this is H. Now, most times the trapezoid was laid on its side, but we want to keep it upright because of the fact that ours is upright in our diagram. And to be able to find the area of that, you took A plus B, add them together, and then divided by 2. Because if you get the average of them, you can make it turn into like a rectangle. Because if you remember, a rectangle is just base times height. Well, this is A plus B divided by 2 times height. So this, remember, is h, right? And this was f of x, and this is f of x plus h. And this would have been x and x plus h. Now, delta A is the change in that trapezoid. Okay? So delta H is approximately the area of the trapezoid PQRS. Okay, now I'm just going to, the area of a trapezoid was height times A plus B divided by 2. That's how you find the area of a trapezoid. So we kind of want to get ours, so it's using the, so ours will be h times f of x plus f of x plus h. Okay, and then we're going to take 1/2, because we could put the 1/2 out front here if we wanted to. And since we're using the, oh no, that's all I need to put for that one. I'm going to, so that is our formula for a trapezoid. Okay, so now I'm going to try and take this part here of our limit formula. I'm going to replace it with this, because we said the area of that delta A is the area of the trapezoid. So if I'm going to do this formula here, and I'm going to take this and replace it with the area of the trapezoid formula, which is 1/2 h f of x plus f of x plus h, and that's all over this h that was right there. Okay, you can see right away now the h's cancel. So then we have 1/2 of f of x plus f of x plus h. And that's limit as h goes to 0, right? Well, now I can put h0 in there. So I would have 1/2 of f of x plus f of x, which is 1/2 times 2f of x, which equals f of x. So what I tried to show you is that if I take the derivative of the area, I get f of x, the equation of that line. Now, that is a good enough proof to say, well, if you give me the equation of the line, if I take the antiderivative, I should get the area. Okay? So in conclusion, if you take the derivative of area, you get f of x. Okay, therefore, if we go the other way, the antiderivative of f of x is area. Okay, so this was how the proof, and again, do you have to memorize this? No, but I need you to see it, so when you see it again, right, then it's not brand new. Okay, so just a couple more things. Now, finding the area under a curve. Now, just so you know, area under a curve. Now, obviously, if you took the total area under the curve, when would you know where to stop, right? So it is defined to be the area between curve and x-axis. Okay, so that way you know it's not just going to, because under something you're like, well, how far do you go? So it's kind of like the 0, x equals 0 line, or sorry, y equals 0 line, or the x-axis. Okay, so we're just going to, now since a of x is the antiderivative of f of x, it follows that if you take the derivative of the area, you get f of x. So the derivative of the area gives you the function. Now, a of x is the same thing as capital F of x plus c. Now, the initial condition at A, so if I was to find the area at A, you see how close this would be here? There would be no area, right? So the initial condition at A is the area 0. Like, can't take the area there. It's like one dimension. So the area at A would be the antiderivative of A plus C, which would be 0. Okay, and then you can just do a little algebra here, just with this part of it. So that one means f of A equals negative c, right? If you just brought the c, or better yet, negative f of A equals c. So the area at x is always the antiderivative of f at x minus the antiderivative of f at a. And finally, at x equals b, so area at b equals f, capital F of b, minus f of a. So in words, I just want to kind of even, so this means the area under b equals the antiderivative at b minus the antiderivative at a. Antiderivative at a, oh, it's supposed to say minus, I don't know. It's pretty bad when you can't read your own writing. Minus the antiderivative at a. Okay, so this is the important part that you've got to take with you to be doing the assignment. If you want to find the area from A to B, you take the antiderivative at B minus the antiderivative of at A. Okay, areas are always positive. So if your answer comes out negative, do the absolute value. Okay, so here would be, I just want to give you this fast little visual. Say you had to find the area under this curve. Well, when you found out this part, you'll get a positive area. When you do this part, you'll actually get a negative area. So if you added those two together, you'll get an area of 0, and that doesn't make sense. Why would the area be 0? So you've got to take the absolute value of all your negatives, so it would be a positive plus a positive to give you your total. And you're always going to know that by doing a diagram first, and then you're going to be like, okay, that's going to come out negative, so make sure I take the absolute value of that. And that's where the big difference between absolute value and antiderivative and integral, because if you actually found the integral of this, you would get 0. But if you found the antiderivative of it, you would get the total area. Okay, so let's do some so you can start to see this stuff's not as bad as the last 2 pages make it look out to be. Okay, it says find the area under the curve y equals 2x. Okay, so we always want to do a diagram for these. And between lines 1 and 4. Okay, so we would have we'd be going through, because this is 2x plus 0. So the b is 0, right? So, and we'd be going at a slope of about 2. So we're going something like this. It says find the area under this. Okay? And it wants it between 1 and 4. One and 4. Now, just by putting it into the, here, this is what we want. We want this area here, right? Now, what would be my y values here? What do you think that point would be there? 2 and 8. Now, we're using this example because it is the simplest one I could give you. A grade 8 could find the area of this one, okay? Because he knows, oh, that's just a trapezoid. And trapezoid is the 2 heights divided by 2 times the h. And h here is 3. Okay, so area of a trapezoid is h times a plus b divided by 2. So h is 3, a doesn't matter, a and b can't really mix up. We'll go 2 plus 8 all over 2. So 2 plus 8 is 10. 10 times 3 is 30 over 2, which is 15. The area of that is 15. Okay? So that's totally doing it junior high, right? In fact, you probably have to you do that in like grade 6 even. But I'm going to show you how to do it using your new antiderivative way. Okay? So we want to find the area from 1 to 4. So you always go left to right when you write those subscripts. See, there's 1 and 4. But then when you write the subtraction statement, you go right to left. So that would be the antiderivative at 4 minus the antiderivative at 1. Because you always want to go bigger minus larger, right? So that's going to give you a positive, right? But when you put it in the subscript right from the beginning, you do it in the same order you would read it. Okay, now what is our integral? So we got y equals 2x. What's the integral? Y equals 2x squared divided by 2 plus c, which is y equals x squared plus c. Now you're going to find that when you ever do area, you can ignore the c. But I want to do just this one with the c in it to show you why. Okay? So from 1 to 4, we're going to do f of 4, which would be 4 squared plus c minus f at 1 would be 1 squared plus c. Now at this point, you should always see why the c's would go away. Okay, because you always got your plus c minus c. Just want to show you once. So then we've got 4 squared is 16 minus 1 is 15. Okay, so that's a pretty good proof there that it works. Again, you're probably asking, well, why do we have to do it that way? Why couldn't we use our trapezoid formula? Because every other curve, the trapezoid is not going to serve you. Okay? But there is, and you'll do this later with Riemann's sum and stuff, that you take all of your area and you break it up either into little rectangles or trapezoids, add them all together, and then you get very close to the right answer. Take the antiderivative, and Dyson, is this stuff too easy for you? No? Okay. Okay, find the area under the curve of 2x squared plus 4. Okay, so 2x squared plus 4. We're going to be up here. And it wants from -1 to 3. So I want this. Okay, so since we always know we're going to need the antiderivative would be y equals 2x cubed over 3 plus 4x to the 1 over 1, right? And I don't have to put the over 1. And I'm not going to put plus c anymore because we know it's going to cancel. So this says find the area from -1 to 3 under this curve. That equals f3 minus f at capital F, f at -1. So Let's do it. So that's 2/3 times 3 cubed minus 4 times 3. We use square brackets, and then we got to start with the new 2/3 times negative 1 cubed. I have no idea. Plus 4 times negative 1. Okay, this gives you 30 minus negative 14 over 3. Now, because this is all above the x-axis, we know we don't have to take the absolute value of it, right? So you don't take the absolute value of those separate ones. Do the math like it is, and the 30 minus 14 over 3 gives you 104 over 3. Okay, it helps a lot to have a diagram on these so that you'll find that the graphs are not going to be that difficult. Okay, so we got x squared minus 16 is the next one. So negative 16 is down here, and it's going through. So this is negative 16. Now it says determine the area of this graph between the roots of the function. Okay, so we are doing this area right here. And remember, area is always to the x-axis. Now, the roots. Okay, well, let's find the roots. 0 equals x squared minus 16. 16 equals x squared. Plus or minus 4 equals x. So this would be negative 4 here and 4. Now, because this is under the x-axis, I've got to be thinking absolute value. Okay, so I got negative 4 to 4. The area from negative 4 to 4 would be the absolute value of f of 4 minus f at negative 4. Okay, I guess we should, yep, just the drawing. Because I drew it and it said between the roots, right? So if I was to do this one, like it just goes up forever, right? So it's going to have a bottom and a top to be able to do it. Okay. We haven't done the antiderivative yet, so that would be x cubed divided by 3 minus 16x. Okay, or 1/3 x cubed, whatever. So absolute value, 1/3 times 4 cubed minus 16 times 4, bracket, minus square bracket, 1/3 negative 4 cubed minus 16 times negative 4. So this works out to be 64 over 3 minus 64. Still got my big absolute there. That's negative 64 over 3 plus 64. Okay, now looking at this too fast, you'd want to cancel those 64s, but they're not going to cancel because you'll have a negative 64 minus 64 there, and you'll have a 64 over 3 plus 64 over 3. So absolute value of 128 over 3 minus 128. This gives you absolute value negative 256 over 3, which equals 256 over 3. Okay, determine the area of y cubed. Okay, and then again, this goes to Simone's question again. It's really hard to tell what you're finding until you actually just do a rough drawing. Otherwise, you probably will not be chasing the right question. Okay, so there's x cubed. And we are finding the area from -3 to 2. Okay, so that would be this. So, how do we write something like this up to kind of keep it organized and looking? So we're going to call it area total. Is going to be the absolute value of area from -3 to 0 plus area of 0 to 2. And you don't have to put absolute value signs over the, you could, I guess, if you wanted. But it should come out as a positive. Now, our antiderivative is y equals x to the 4 over 4. So area total would be the absolute value of 0 to the 4 over 4 minus, I'm going to put -3 in there, which would be minus 81 over 4. Plus from 0 to 2, so I'm going to do the 2 first. 2 squared, or 2 to the 4, sorry, over 4, minus 0 to the 4 over 4. Area total, this works out to be -81 over 4 plus this entire thing turns into 4. So at this stage, area total equals 81 over 4 plus 4, which equals 97 over 4. That makes sense? Okay, let's just do one more that's just kind of taking a twist on it, where they're going to leave out a number in the equation and then ask to go backwards and find out what a is if they give me the area. Okay, so this one, 6x squared plus ax plus 8. Okay, so that's here at 8, and it's just going like this. And it wants from 1 to 2. So here's 1. Here's 2. We know that this area is 13. That's from the question. It says the area is 13. Determine the value of a. Now we know that area from 1 to 2 is the antiderivative of 2 minus the antiderivative at 1. Okay, what is our antiderivative? Well, it would be 6. So f will equal 6x cubed over 3 plus ax squared over 2 plus 8x. So this would be 2x cubed plus 1/2 ax squared plus 8x. Okay, so 13 equals 2 times 2 cubed plus 1/2 a times 2 squared plus 8 times 2 minus 2 times 1 cubed plus 1/2 a times 1 squared plus 8 times 1. So 13 equals, this is 16 plus 2a plus 16 minus 2 plus 1/2 a plus 8. So 13 equals 32 plus 2a minus 10 minus 1/2 a. Okay, 13 equals 22 plus 3 over 2a minus 22 to each side, and I will get negative 9 equals 3 over 2a. Multiply both sides by 2/3, and I get negative 6 to equal a. Okay, so instead of this, I've given you an activity that has all of the answers. So activity 10.1. And 10.2 is also there. So that'll be for tomorrow.